This is my Yashica Electro 35 GSM. It was sitting in my broken camera pile, which is pretty extensive at this point. My friend Dennis came over and said, "Hey, that's a pretty cool camera. I used to use one all the time." I said, "This one's broken." But it got me thinking, and I started looking up on the internet how you might fix a broken light meter. It's aperture priority only, so it does not work if the light meter is not working. Or just at one shutter speed really, which is ostensibly a 500th of a second. Anyway, I got to doing a little Google research on the circuit diagram of the thing and how to fix it. Did not entirely figure out how to fix the aperture priority section, but I saw a flickr post from years ago from somebody who added manual shutter speeds to their Yashica. I'll put the link below to his work. Anyway, I added manual shutter speeds to this camera, and I'm going to do it again to this camera, make a little DIY so you can also add manual shutter speeds to yours, hopefully not ruining the aperture priority function as well. So here's a little demo. Let's see, the camera works as normal, and I just added this little switch up here. I'll do a little detail cut in so you can see. I had to push the over and under lights a little bit to the side, so they're misaligned a little bit in the viewfinder in order to fit this little rotary position switch. And I made a little 3D printed knob here. I'd like to make a little nicer one, but for now, you put the camera on bulb, and then it transfers control over to this guy, and then you have manual shutter speed. So here is, let's see, that's a fast shutter speed. Let's see if I can find bulb here. Yep, that's bulb. Oh, no, that's 1 second. That's bulb. This should be a 2/50th, 1/25th, 60th, 30th, 15th. See if we can hear that. Eighth, quarter, half second. Okay. Again, this is the shutter speed selector. It's on half a second right now. I'll open it up so we can really see the shutter. Open up the aperture. Here is half a second. And then here's a different shutter speed. It's a fast one. Here's a little inset of the camera that I modified first. It's got the shutter speed dial here. I'll pull this knob off. You can see that I put the dial right up next to where the over and under, or slow and over, lights are. I had to move them a little bit to the side this way so that they are not in the proper position when you look through the viewfinder, but they still work. That's a preferable spot for me, to have the adjustment in the top. There's also room in the case to put the knob out the side here, but I thought that would interfere with the strap lug when I was carrying the camera around. But I'm thinking on other cameras like the GX or the CC, this might be the only place where a switch would fit. Here is my second camera that's working properly except for the battery check light, but not a big deal maybe. First I'm just going to show you the tools that you need to get inside the camera and modify it. A set of jeweler's screwdrivers are helpful. You don't need this many, but you'll need a couple small Phillips and small flathead screwdrivers. Also, for really fine flathead screws, I like to use a knife to get them going. You'll need tweezers. These are an electronics tweezers. They've got nice pointy tips, or they did before I started ruining them, opening cameras with them. And then I've got a series of these spanner wrenches. They're pretty useful. You probably only need one with pointy tips like this guy, but having a bunch with pointy tips and flathead tips are always useful. You'll also need a soldering iron, some solder, a little doohickey to scrape the solder off the end of your soldering iron. I used a bunch of these shrink wrap tubing and just, let's see, use a Bic lighter to heat the shrink wrap tubing. A couple of small wires, set of resistors, we'll go through that later, and I made a little Arduino shutter speed tester, which I will go over in another video, so that you can calibrate the resistors in the analog circuit to specific shutter speeds for your camera. Another couple of things you might find useful is a multimeter. Anytime you're doing soldering, you don't need as fancy a multimeter as this one, but just something that can be used as a continuity tester is really helpful when soldering. And a bunch of little alligator clips and some magnets for catching small screws and pulling them out of bodies or off the floor where you lose them. Maybe most important of all, you'll need a small rotary 10-position switch or some kind of switch so that you can change the resistor in the circuit path to change your shutter speeds. I got this tiny little one. It was pretty fancy, about as expensive as the camera itself. You could really use anything, but I found that this guy fits nicely inside the camera with, you know, only having to move the over and under lights just a little bit. I'll put that aside. Okay, so to disassemble the camera, first things first, get yourself a little tray to put your pieces in so you don't lose your tiny screws. I'm gonna lift up on this guy to open the film back. Take any sort of screwdriver and stick it between this guy. As for camera disassembly and cleaning, there's plenty of good YouTube videos on it, so I'm not going to spend too much time here, but I'll go through quickly how to open up your camera. So I first take this guy off. It sits over there. Then we're going to remove the film speed dial. Take your tweezers or a small spanner wrench, get inside those two dots here, and lefty-loosey. That guy should all come out. This is a series of pieces here. You've got this small little guy, and then the plate, and then this plate, but I like to keep them together. Put those to the side. Take the top plate off of the wind lever. Again, with these tweezers or a spanner. I like to try and remove this all as one assembly, although it's this top screw, this spring washer or whatever you'd call it, the wind lever itself, and then there's an alignment plate. Take note when you disassemble that this dot can go here or here, but it goes on this side of the alignment plate. Okay. I like to put all these together in my tray. Okay, next we're going to remove this battery check cover with a small Phillips screwdriver. I like to take a little magnet. Where's my magnet? Oh, here's a magnet. Take a little magnet if you don't have a magnetized screwdriver and just put it on there so that it'll grab the screw when it is totally loose. So, first these two screws. Here's one. Here's two. Just take note, when you remove this, the battery check button is actually free floating in there, so that might fall into your camera. Here it is. Pull it out. Just don't lose that. Okay, and then we're almost there. There are only 3 more screws. There's one here, and one right here next to the strap lug. So I'm going to remove those and I'll be able to pull the top off the body. One. 2. 3. This is a good time to clean your camera and clean all the pieces. I like to do it with a cotton swab and some alcohol while you're at it. And just the top plate will just come off vertically, but keep in mind it is attached via this cord to the PC sync and the hot shoe if you have a hot shoe, and this is pretty easy to break, also pretty easy to fix. I've broken and fixed it on the other camera. You may want to tape this to the side of your camera or just cut it and solder it later so you don't have to deal with it in the way, but I'm just going to leave it dangling and we'll fix it if it breaks. These are the over-under indicator lights. I'm going to remove that. And this is the main circuit board right here. It says Copal on it. I guess Copal made this, or at least the board. It's kind of funny. It's not a PCB at all. It's hand soldered like a regular perf board or proto board. And you can remove these 2 screws right here, which holds down these indicator lights and 1/2 of the main circuit board with the light meter, and this screw right here. We're going to take those off. Go. You're going to want to make sure that you push down pretty firmly as to not strip these tiny little screws. Let me see if I can move the camera so that it's a little closer and you get a better view here. And again, the screws I just removed to remove this over-under lamp housing and the main circuit board with the light meter assembly were right here and right here on the back post. 2 little black screws. Okay, so first thing, I'm just going to slide this out of the way. I'm going to slide the main circuit board up and out of the main camera body. There are a whole bunch of wires here, kind of like spaghettied. I'm just going to work them gently so I can get a handle on it. So we're going to add a switch with a resistor in between 2 contact points. So the first thing we're going to do is solder on 2 lead wires, and then we can put in, just with alligator clamps, different resistors and measure the resulting shutter speed so that we can calibrate the resistors to specific shutter speeds that we want. So the first place we're going to want to add a wire is this solder bus on the back of the camera, or the back of the circuit board rather. Let's see if I can pick that up and show it a little bit more. It's kind of a T-shaped bus right here, and I'll post a link to the original circuit diagram that had this modification on, I think it was Flickr, in the bottom of your screen, so you can take a look at the circuit diagram more technically, but this is where it is physically. And so it's anywhere on this bus we want to solder a new lead here without desoldering anything else that's on this bus. And then the other place is this orange wire right here. Now my original design, I was just sort of testing it, and I wound up soldering another wire straight to this contact that the orange wire went to. But this time maybe I will clip the orange wire and add it in the middle here so I don't risk bending these little metal contacts here while soldering them. Okay, so I'm going to do the tricky one first. See if I can do that in a way that you can see. One thing I really find indispensable while doing work like this is a pair of helping hands. It's just 2 little clips. Sometimes they've got a magnifier if you haven't dropped yours too many times. Just use one hand to hold the board. Try not to ruin anything. I'll use one hand to solder on a lead. Where are my leads? Okay. Here's just a little wire. It's probably a good fast forward point in the video. And you want that wire firmly pressed against the solder joints, so when everything heats up it'll get sucked right in. This T-shaped bus right here, that everything soldered to this is a good junction to add this first lead. So I'm going to go warm up my soldering iron. You're going to want to have a little scraper to make sure your soldering iron is nice and clean once it's hot, so you don't get any junk in that kind of little hard to get to spot here on the circuit board. First thing, you tin your tip just a little bit. I like to use non-lead solder, tin antimony. It's nice for doing it indoors. Open a window, turn on a fan, what have you. Don't breathe too closely. So add a little solder to the tip just so it can conduct. There are probably many of you out there can solder way better than I can. But I'm just going to heat up this puddle a little bit on top of the wire. Quickly try and add some new solder that will get soaked up into the original, probably lead solder. There we go. I want to be kind of quick about it because I don't want anything else to desolder from the other side of the board. Okay. Now that you've got that, it's always helpful to test your connections with a continuity tester, just generally on the ohm setting of your multimeter. Let's see if I can turn this on. Basically, all that's going to do is tell you when 2 leads are connected, right? So it'll beep when these guys touch. Okay, so put this down on the bus somewhere, touch the other end of the thing, and hopefully it will beep. That's a good solder joint. Okay, on to the next one. So the other lead we're looking for is on this orange wire that dead ends at this little metal spring contact, which is opened up when you push the shutter button. You could, as I did, solder directly to the end of this wire, but I'm just going to clip it in the middle here and add a lead just so I don't risk soldering this connector together or otherwise heating and damaging it. Okay, so now you want to strip them just very carefully at the ends here. Okay, that's one. Here's the second guy. I'm actually going to hold it so I don't pull the end off. This is all more fine than I'm super comfortable working with, but it's alright, just have to be nice and gentle and slow. And I did it. I pulled this guy off, so I'm going to strip both ends and solder on a new connection right here. I added this end of the lead right here. See if I can show it a little bit better. Added this end of the lead from where I ripped the other end of the wire off, and then I soldered these two together so the current path can go this way and also comes off in the middle. So much for not soldering to this little spring connector. Anyway, good thing to do is use your multimeter, connect one end to the thing you've just soldered, set it again to continuity testing, and then just check to make sure. Oops, I said set it to continuity testing. There we go. And then just check to make sure that your solder joints are connected. Okay, that's working. Solder joint is connected. Then I'm just going to slip this underneath this spring contact to make sure that I didn't ruin the contact and that it does go disconnected when I push the shutter button down a little. That looks good to me. So the next thing I'm going to do is just take a little piece of shrink wrap and slide it over this joint. And I think the professionals have heat guns, but I'm just going to use a Bic lighter here just to decrease the chances that I'm going to get a short against the body or any other wires. Nice and quick, you don't want to melt anything, just shrink this tubing. So now I've got my two leads, and I should be able to either short them or add a resistance or keep them open to change the shutter speed. So I'm going to put on some alligator leads for testing, put the battery back in the camera. Generally when you're doing soldering and things like this, you want to pull the battery out so you don't short and burn anything out. And then we will test a couple of different resistors and check for shutter speeds. Okay, at this point you're going to want to temporarily reattach the winder so we can test, so we can test the shutter speeds. We need the winder to take pictures. Again, this little circle you want facing you rather than facing the front of the camera. Just screw that on, make sure the little wind lever is seated in that hole. It's nice and straight. Just finger tight is good, so that we can wind. Now if it's on bulb, it should fire on bulb. Yes. And if these two are shorted, say, here's where an alligator clip comes in handy, we should have our maximum speed, which is theoretically a 500th of a second, but in a camera from the 70s I've found we're lucky if we get about a 300th of a second. Okay, so these wires are connected just through this clip here. Let's see, is this fast? Oh yeah. Okay, so the next thing I'm going to do is set this camera up with my Arduino shutter tester, and we're going to place different sized resistors between the hot and cold leads, and we're going to measure out which resistors yield the correct shutter speeds for our dial. And those could be anything you want, but standardly it would be something like 1 second, half a second, quarter second, eighth of a second, 15th of a second, 30th, 60th, 125th, 250th, and maybe a 500th, but again, I think it's pretty rare to find something that's, 25, 35, 40 years old, where the shutter lube or mechanical lube hasn't gummed up just a little bit, such that the maximum speed on these guys I've found is generally around a 300th of a second. Anyway, we will set that up and take a look. Micro insets, just so you can see on the main circuit board. This is the bus that you want to solder the first lead to. This is my lead. Oops. Yep. There we go again. It's this T-shaped bus right on the back here. Anywhere you want to solder is fine. Just make sure you don't desolder everything while you're adding one lead. And here's the second lead. It's this orange wire here that originally goes to this spring contact connected to the shutter button. I added my lead in the middle so that I wouldn't have to solder to the spring contact, but then I broke the spring contact and just added this little black wire here. But again, you could add the contact here or anywhere along this orange wire. The orange wire goes into the lens assembly, so it would be much more disassembly to add the wire down in here. Okay, so I made a little Arduino shutter tester here, which I will go over how to build in the next video, but you're going to need one or any sort of shutter timer tester so that you can pick resistors that correspond to the shutter speeds you're looking for on your dial. Anyway, just a quick overview. I've got an Arduino Uno. This is just sort of a prototype, so I've got it hooked up to my computer and I'm reading it over the serial port here. Got a small laser module just held up with my helping hands, pointed at the center of my lens. And then on the back here I've got just a little, let me see if you can see it there, just a little laser sensor. You can see when I open the shutter that I've aligned the laser relatively through the center of the lens to hit the sensor. So there it is. Close the shutter, and let's see. When I do that, the tester, here I'll fire one. The tester will just tell me how long, in fractions of a second, and a little bit of other information, that the shutter was open for. Open, close. There we go. With your shutter tester all set up, what you're going to want to do is grab a lead wire. I like to use these alligator clamps, connect it to each lead, and then we're going to connect these guys either to short, to open, or a series of resistors which will correspond to different shutter speeds. So let's try one open first, should be bulb. Yeah, and that basically stays open as long as I can. And then we'll try one closed. This is a short. See how fast the mechanical shutter is without any interruption by the solenoid escapement. So it's about a 325th of a second. Try this again. 341 of a second. 336 of a second, and that's all pretty consistent with what I've measured across older cameras of this era. And then I'll take a shot where you can see the screen. I'm going to fire again with the two leads shorted. We get a 326th of a second. I'll go again. 290th of a second. It's a little variable. One more time. 291st of a second. 91st. Yeah, so I'd say this is right around a 300th of a second. Unshorted, I'll add a small resistor to make the max speed at 250th of a second. So it's going to be handy to have a whole bunch of resistors. I tried to do this with a rheostat or a potentiometer earlier, and it was really tough to get precise readings off the potentiometer and get a range that I'm looking for. So just a bunch of discrete resistors and then a piece of tape that's sticky side up. I made a loop out of this guy so that I can stick my resistors to them, and a piece of tape so that I can mark what the corresponding shutter speeds are to those resistors. Okay, so last time I found it was a 300 kilo ohm resistor that yielded 1 second. I'm going to start with that. So you clip one to one lead, the other side to another lead, doesn't matter which way. And I'm just going to fire the camera and see what the shutter tester tells me. 1.62, 1.66, 1.54. Got all my various resistor trading cards here. Okay, here's a 47K ohm. Let's try 347K in this guy. See if we can get 1 second. I'm just going to twist these two together. That'll give me resistance adds in series, so this should be 347K. I'm just going to hook this up like this. Either ends are not twisted together, and try it out. .36. So we're going in the right direction now. Need a little bit more than 347K. Let's see what other options I've got. Okay, let's just try a 470K resistor and see what that yields. Okay, 1.08. That's great. 1 even. 1 even. Let's try this again. 1 Mississippi. 1.01. Okay, so I would say that for 1 second, the appropriate resistor for this particular camera is 470,000 ohms, 470K. So I'm going to put this over here and mark it 1 second. My pen. 1 second. Alright, and so this is not necessarily a linear scale, but let's try something like 220 for half a second. And here's a 220K ohm resistor right here. I'm going to hook it up and do the same. Basically, you're just going to repeat this process over and over for half a second, for a quarter of a second, for an eighth of a second, and so on and so forth, or any wacky in-between non-standard shutter speeds you like. Alright, so here's 220K. 2.11. That's 1 over 2.11 of a second, so almost a half. 2.18. 2.12. Okay, I would say that's it within 10%, which is kind of what I'm looking for. I'm going to call this 220K resistor half a second. I put it over here on my tape, label it half a second, and then repeat. Okay. All of my resistors, and on this side, I don't know if you can see the markings, but I've labeled 1 second, half a second, quarter second, eighth of a second, 15th, and so on. And that is my entire resistor set corresponding to the correct shutter speeds that I'm going to modify this camera with. So I'm going to put away my shutter tester now and get out my soldering iron. This is my 10 position switch. It's a single pole, single deck, 10 position rotary switch. Basically, this side has a little knob that you can turn through different positions. Hard to show. And I ground it down just so it wouldn't stick out of the camera so much. And on this side, it's got 10 positions or 10 pins around the edges here, and 1 common pin in the center. And basically, you know, on bulb, well, for each one of the positions that this knob turns to, it shorts this center pin to one of the external pins. And so for bulb, I'm going to leave it open. So this will be shorted to a dead pin or an open pin that's not connected to anything. And then for each one of the other positions, this center pin, which will connect to one of the leads, will then connect to one of the resistors or resistor sets that we calculated yielded a particular shutter speed in order, right? So we go bulb, 1 second, half a second, quarter a second, and so on. And then we're going to try and jam all of those resistors into the top of the camera. So the first pin I'm going to solder to is that center common pin, called this guy. So you want to have a helping hands for these and set it up while your iron's heating. I'm just going to try and get some good physical contact here between the two pins, which you can probably see on the camera a little bit better than I can with my naked eye. See? Okay. Actually, you know what? I'm going to cut down these pins first because they're a little long to fit inside the camera. So I think this switch was designed to go in a through-hole board, not necessarily soldered directly to. I've considered printing a PCB to miniaturize this to use surface mount resistors, but that's a little bit more work for maybe the one camera that, that I'm going to wind up doing. If there's a lot of interest on the internet and people want a PCB to add surface mount resistors to one of these things, maybe I will have one of those printed up at Osh Park. First lead I'm going to add is this black lead in the center, and I think I'll probably use reds on the outside, but you can use whatever color you want, obviously. Okay, get a good mechanical connection. Scrape off your soldering iron so it's nice and clean. Put a little dab on the end to tin it, if I can find the end. The thing about this sort of soldering is you want to be pretty quick about it. Let me move the camera a little bit. You want to be pretty quick about it just so that you don't heat up and or melt any of the internals of this tiny little switch. Alright, here we go. A little solder on the tip. And heat the wire. Lick the solder into the joint. Come on. There we go. This is one of the hard parts. It's not intellectually difficult, but physically kind of tough to make such tiny solder joints. Okay, so I think that first connection's pretty good. So what I'm going to do is slip one of these shrink wrap tubes over it to cover the connection so it can't short to anything else, and I'm going to use a lighter to just shrink it over there. Okay, that's off the helping hands. I'm going to cut this down. I don't need the full connector. Let's see if this small one will slip over. Yeah. Will it slip over my solder joint? Yes. And so you want to get it nice and snug against the base of the switch. Break out your big lighter. Again, this is not a soldering tutorial. There's lots of way better soldering tutorials and such on YouTube if this is unfamiliar to you, but just wanted to give a little, this is how I did it. And when this tube shrinks, it's going to shrink up from the end, so I'm going to want to try and push it down against the base of the switch as I go. So that's it. Pretty little amount of heat. I, again, don't want to melt anything inside the switch. Just want to get this little shrink wrap tube to stay on. And I'd say that's pretty good. So it doesn't really matter which pin I start with. I can always calibrate the knob or dial so that it starts on one side or the other. I guess it does matter to you maybe whether you go around clockwise or counterclockwise for you know, slow to fast, but all the same to me, I guess. I don't really have a preference, I don't think. Maybe I will find a preference later. Alright, so the first one is probably the least tricky one. The last one is the most tricky as you get more and more wires in the way. Touch the wire, feed the joint. There we go. Okay, and I've added a little piece of shrink wrap to the end of that wire where it connects to the switch. And here I'm just going to put in line that first resistor. I think it was like a 400 and something K ohm resistor that corresponds to 1 second. I'm just going to try and solder it pretty quickly so I don't melt anything inside the resistor or the wire wrap. And heat the wire, feed the solder in. Okay, that looks like a pretty good joint. So that's 1 second. One next to it will be left open, and then I'm going to solder on the lead for half a second. Come from under, but I'm going to go from over so I don't heat the next joint that I already did. Oh, and it looks like I bridged 2 pins, so I'm just going to heat that up again and make sure that I'm not shorting these 2 pins together. And it's really, really tiny. Time for a solder sucker. This tool is called a solder sucker, I think. It's kind of like a blackhead remover. It's like a spring-loaded vacuum piston. Basically, I'm going to heat the solder up, prime the piston, and then when the solder is hot, I will fire the piston and just suck a little bit up into the tip of this thing. A lot of people like to use braided copper or something like that to suck solder up, but this is my preference. You can use whatever, and almost inevitably you will bridge 2 pins or connect 2 things that you don't want connected if you are not amazing at soldering. There we go. By the way, this is also much easier if you're not trying to film at the same time and doing everything at a weird angle. Just concentrating on soldering is a little easier. There we go. I've got it nice and butted against the switch. I'm just going to hit it with the lighter for a second. Shrink it down. Okay. The distance that you put the resistor on the lead is sort of determined by how they're going to fit in the camera. I've found that you're going to want to stagger the resistor distances just a little bit so that your whole spaghetti mess of leads isn't all thick at one point, but they also need to be a little bit, like maybe an inch away from the body, such that these wires can bend around and the resistors can sit in the back of the camera case rather than in your rangefinder, which would be no good. Just a little bit of oxidation or carbon on the tip of your iron will stop it from conducting heat. There we go. I like to heat from the bottom when possible. Alright, I'm going to do the next 1, 2, 3, 4, 5, 6, 7 of these, and then I will come back. I don't need to make you watch me fiddle around with them, and then we will test all the joints. Alright, and I'm back, one Mark Maron podcast later. I've soldered all of the leads to the back of this guy, added the resistors with no shrink wrap yet because I want to test it. I just broke out my ohm meter, connected the negative, or either side is fine, to the center lead. That's the main pole. And then going around, I'm going to clip the other lead to each one of these guys and make sure that I have the right resistance. So this is 469, which I believe is 1 second. And I'm just going to go over to the next guy, and it should have infinite resistance. OL is overload. And then I should be able to click the switch over one. Not sure which direction, I think this way. Oh, yep. And I have 220 ohms. And then I'm just going to check the next one. Basically, this is just a continuity check before I seal everything up to make sure that I have soldered everything correctly and there's no breaks. So, again, overload on the next one, and I rotate the switch one more position. And we get 119 ohms, 120 ohms, cool. And then I go to the next one, and sorry, that's touching the wrong wire. Move up the shielding. And I'll check the next position. 56, great. And then the next wire is up here. Overload and 30 ohms. Basically, I'm just going to go around and make sure all of the wires that I've soldered on have a good connection and I'm reading the right resistance. Alright, so I've checked them all. Everything looks good. I'm sure I'll break a solder connection while putting it all together in the camera body and have to redo it. But for now, we're good. Now what I'm going to do is I'm just going to put some shrink wrap over all of these soldered on resistors. Again, this is not the proper way to do things. I think the best way would be to have a PCB made and put on surface mount resistors rather than trying to make them inline. But in keeping with 1970s technology and not doing too much CAD and just making one or two of these things, I'm going to do it like this. So I find a piece of fatter shrink wrap in the shrink wrap pile. This green one looks alright. I'm just going to slip it over all of these electrical contacts. I'm not going to shrink it immediately. I'm going to leave everything on. I'm going to connect all of the ends of all of these except for the center pole, and then I will shrink wrap and solder them all together into one big ol' spaghetti spider mess of wires. Alright, so I've got the pole lead over here that has no resistors on it, and then all of my resistors or resistor sets are inside these shrink wrap tubes, and I've just twisted up these ends. And so first I'm just going to shrink wrap all of these tubes together, and then I'm going to put a dot of solder here, and then we're going to retest to make sure that I didn't ruin everything by connecting one lead to the pole and one lead to this guy, and then I will turn the switch and make sure that all of the resistances change accordingly. Here is my lighter. Here we go. So do a quick shrink of the shrink wrap. Pretty simple. Try not to melt the solder. This gives it a little bit of strength, but also just makes sure that nothing's going to short out inside the body. Okay, I like that. Okay. So now what I'm going to do is hook one of my leads to the center pole, and then the other lead to this collector here. Let's see if I can turn this on. Okay. Then 2 kilo ohms. That's open, that's for bulb. That's 468, that's for 1 second. 220, that's half a second. 120, that's quarter of a second. Come on. It's hard to rotate here without a knob on it. 56. 30. Use little pliers to rotate this knob without a knob on it. 16, 7, 3, and then back to 2. So I would say electrically this is working. Now we begin the annoying job of fitting the whole thing back into the camera body. And I've routed the 2 leads, one here and one here, out the back, because that's where I'm going to stick this whole resistor switch contraption. You want to make sure that this guy can come through on the bottom without interfering with things. Seems pretty free of anything, put in this second screw. So also the second screw holds the indicator lamps for slow and over, and they actually just slide in here. And I found this is the smallest switch I could find. Still, I'm going to need to slide the indicator lamps to the viewfinder side of the body, which is going to make them a little misaligned in the frame. But that's really the only way that I can get this all back in the tight package that it came in. So I'll do an inset shot here. But basically, I've got the front of this indicator lamp mask right up against this piece of glass here in the viewfinder. I might even just kind of pinch these guys. You know what, actually, and make sure that the wires are below the bracket. Okay. It's kind of ridiculous to have a camera that the electronics are actually physical wires rather than PCB traces, but also is kind of nice for working at home with just a screwdriver and whatnot. Okay, so I've got these guys in. One thing you're going to need to do is just trim the corner of this PCB where it says copal. I'm going to get in nice and close and show you that trimming. So you want to be sure not to trim off any of the solder joints, but there's this extra sort of piece here that's going to get in the way. So I'll just kind of crack as I clip. There we go. No turning back now. Just clipping off extra pieces of that circuit board. Alright, and that's going to give us plenty of room in here to work the new variable resistor switch, or I don't know what you want to call it. I have found that this best works with this guy wrapped kind of like an S through here, kind of like that. I'm going to fiddle with it a little bit to see if I can bend everything without breaking my solder joints to get it into place. I have now soldered the two ends to the two leads we put on the camera body. I put a little bit of electrical tape over this hot mess over here so that it can't contact anything on the circuit board, just as an insulator. I've got it kind of bent in a way that I think it's going to fit into the camera body. Now what I'm going to do is just drill a hole, let's see, right kind of half in this plastic and half in this metal part. I've shifted the lights over. You should still be able to see them through these two windows, but they'll be shifted this way, so maybe not as bright, but that's sort of where I can fit it without tampering with the ASA dial indicator. So now I'm going to drill a hole here and we'll squeeze her all back together. Now this is something surely best done on a drill press, but I don't have a drill press at home, and so I'm just going to kind of be a little careful and oops, try it out here, kind of maybe use the drill a little bit as a mill and pull it to the side. Okay, you want to save this little plastic window to glue back in. It's getting pretty round there. Oops. Oh. And I've managed to break off this flash sync connector, but we'll reattach that in a minute. Yeah, I would say that's pretty good. Maybe I'll make it a little wider, just for ease. Try not to get too much, metal and brass dust inside your camera. That will really, really gunk your shutter up. Okay. Yeah, I would say that fits pretty nicely. I'm gonna clip the corner of this little red window and glue it back in. This is kind of not for the squeamish, destroying some camera parts here, but maybe it's for the best, or for science. A little bit of super glue will do nicely. Let's see. Okay, just, drop on the edge here. Okay, good as new. Okay, so now it's a little tricky just wiggling this guy on. As you can see, there's way too many wires jammed in the back here, but kind of have to just massage them and then massage them out of the way of the battery check button. But they're all a little flexible. I'm not going to put the top nut on this guy until everything is seated and I can make sure that the ISO dial works and everything else. I had to take off the wind crank that I had put on earlier just to slip the top back on. And I think we're on. And so the first thing I'm going to do is just put in these 3 screws here, here, and here, and then we're going to check it again before I do anything else. Then I'm just going to hand tight put on the wind lever so we can check to make sure that everything's working before I button it up. So again, there's this little disc. It can go on either like this or like this. You want the little hole, the alignment hole on the side to be towards the back side of the camera. Then on goes in order this wind lever. Make sure its little doohickey here sits in that alignment hole. Oops. Then next comes this spring washer. I usually do this in all one piece, but I'm just showing. And then this little guy. We don't need the tweezers or a spanner just yet. I'm just going to put it on hand tight to test things. Okay, so I'm going to borrow my old shutter speed dial just so I can turn this thing a little bit better. I don't think the numbers are correct. Let's try it out. Sounds like 1 second. That's got to be B, which would make this one a 2/50th. Nope. Seems like we've disconnected one of the leads here. Put a B where it should be maybe half a second. 1 Mississippi. Yep. Now this should also be B. And the next one should be a 2/50th. And a 1/25th. And a 60th. And a 30th. 15th. 1/8. A quarter. And half a second. Yeah, and so I can tell that the half a second lead has come disconnected somewhere in my solder joints internally because it's turned to B. So I'm going to take it apart again and fix that. And then put it back together again. So here we go. So luckily I shrink wrapped only the 1 second set of resistors in yellow against the base of the switch, which means on one side of that yellow shrink wrap there should be an empty pin for B, and the other side of that should be the lead for ½ a second, which somewhere is broken. So we're going to go in and fix that. So again, we've got, I don't know if you can see here, let's check. This guy is the lead for 1 second, which is working, and then this guy is the blank pin for bulb, and then this one is disconnected somewhere, which corresponds to ½ a second. So I'm just going to go in, check the solder joint here between the resistors, and then from the resistor to here, and I'll just resolder that up, and we'll come back, put the camera back together again. Okay, so I resoldered the lead for ½ a second, got it all working. I'm going to put it all back together again. This is pretty fiddly, trying not to break any of these small wires while pushing everything together, but it's doable with a little bit of patience and 70 or 80 tries. You really got to be pretty tight with these lead wires so that everything will fit back here. Like I said, there is the other option of putting this dial either sticking out the front kind of crazily or out the side here, maybe replacing the X sync. There's a whole lot of room for wires and resistors to this side of the viewfinder. I just would prefer it on top of the camera, kind of like standard camera design. So I do all of this wackiness. When you slide the top cover down, there's this moving armature for the light meter. You're just going to want to make sure not to bend that and just sort of push the top cover forward so it clears that armature. These wires in the back are going to want to pull the whole frame back, and that's unuseful to our purposes. And here we go. Okay, I think we are in. I'm going to try one more time to put these screws in and give her a test. I'm going to try and move these wires a little bit so we can get to the battery check button. You just do it with your thumb or one of these guys. I'm going to put the film wind thing on again with the little hole facing the rear of the camera. Put the whole wind assembly back on in one piece. Make sure the winder is seated on the little hole in that first washer. Just hand tight for now is fine. Alright. I hope that's supposed to be bulb. Try one side. That's bulb. It's also bulb. It's also bulb. Okay, I would say that the main pole is disconnected if everything is bulb. So, back apart. This gets a little fiddly. Okay, so I finally got the camera back together and it is working. I had to take it apart maybe 2 or 3 times in the interim, breaking wire connections, jamming everything in here. Again, a PCB with some surface mount resistors would really make this a lot easier to fit in here, but maybe that's another project for another day if a lot of people are really interested in this mod. But I think you could just go out and buy a Canon or a Leica. Anyway, let's check it out. Here should be bulb. I don't know if you can hear that. Put this knob on so we can see it. Alright, when you get this knob back on, it's important to jam something through this film tooth and then tighten it down, otherwise it'll just spin and not tighten. Alright, so I'm going to open the aperture up so we can see the lens pretty well. Refocus this camera. Cameras on cameras. Alright, here's bulb. 1 Mississippi, 2 Mississippi. I'm just going to let go now. And then let's do 1 second. 1 Mississippi. Half a second. Let's do 1/4 second. And 1/8. And 15th. And 1/30th. And 1/60th. 1/25th. And 2/50th. Then it should go back to bulb. 1 Mississippi, 2 Mississippi. Okay. And then 1 second. Cool. Now that I know that that's working and I've got the screws on, I'm going to tighten this guy, reinstall the ASA switch for auto mode, put the nut on this guy, and we'll have a working camera. Oh, and do the back here. So first I'm going to massage these wires back out of the way of the battery check button, whose bulb is burned out on this particular camera, but you're going to want to do that eventually. I'll change the bulb on this guy. Let's see. When you install this cover, this little red button is just free floating against the switch in here and this plate, so you want to stick it through the plate and maybe install it like this so you don't drop the red button inside the camera. And when that's aligned, drop it down. Magnetic screwdriver again. Tweezers are helpful for this. If you can see, right there's a little spot so you can grab this and pull it all the way to one side. And so with this front aperture all the way open, this guy all the way to one side, this should align with ISO 1000 or whatever the max ISO is on your particular camera model. There are a bunch of different max ISOs, but on this one it's 1000. And again, this process should be just about the same for the GSN or GTN or all of those guys. The aperture setting works. One of the things you want to make sure is that this aperture cam internally, the little brass piece, is not rubbing up against this switch. I did that on the first one. This one I put a little bit more over to the side, and now this moves freely. Okay. Alright, the next thing, not totally necessary, but I like to use this little lock washer that came with the switch. Goes over the top of this guy. It'll just put a little tension on the nut, and then this nut comes down. Cheat here and use a little pair of pliers to tighten it. You should use a wrench always rather than pliers for this type of work, but again, this will do. You saw my drill press method. I would like to design a new 3D printed shutter speed knob. This one is really tall. It's for the original height of the switch, but last night I ground down on a grinder the height of the switch to make it a little bit more flush with the top of the camera body. But for now, this one will work, and we've got a working camera. So again, here's bulb, and here's 1 second. And then we can switch it back to auto mode. We're on 2.8. And auto mode seems to be working. And there you have it. That is my new Yashica Electro GSN with a manual shutter speed. Maybe somebody will design a better knob, or I will soon enough, and put the files down below. Again, to do this project you will need a shutter tester and some really commonly available tools. I'll make another video, brief video on how to build a shutter tester. It's maybe $10 worth of parts from AliExpress or Amazon. You don't really need very much computer programming. You can just cut and paste my code. But that'll be in another video, link down below. And thanks for watching.